Today we're talking about Lewis structures. We're going to combine the Lewis dot diagrams. Isn't that what we called them yesterday? Dot structures, dot symbols, Lewis dot symbols, or the dot symbols from yesterday with just single elements. We're going to combine them to form our covalent compounds. So we combine two electron dot structures to show shared electrons, and we also show the unshared or lone pairs. So this is F2, and each fluorine has how many valence electrons? 7. Yes, 7. And we want to look at, let me draw up them individually. So we have F is 7. And then this F has 7 also. And so these two electrons right here are going to be shared between the two fluorines. Let's see if I can get these two, those two electrons. No, once we see which ones are shared and how many are being shared, we're going to erase the dots and put a dash there. And so the dash represents 2 electrons that are being shared. Yep. And that's a double bond. So we'll have double and triple bonds, and we'll kind of go through some examples and show you when you need to do that. So starting at basic steps for drawing Lewis structures, you'll want to write the skeletal structure, so write the 2 F's next to each other. The least electronegative atom is central, except hydrogen. If hydrogen is your least electronegative atom, it's never central. Because if it's central, that means it has 2 atoms coming off of it. So it has to be sharing at least 4 electrons. And how many electrons can hydrogen hold? Maximum. From yesterday, how many? 2, right. It only wants 2. So it can't have 2 elements bonded to it because it would have to have 4, and it's at least 4, so that's too many. So hydrogen's never central, and then if carbon is in your compound, it is almost always central. It's just the way. And carbon will never have lone pairs of electrons on them. They will always have 4 bonds of some sort, whether there's 2 bonds that are in a double bond and then 2 other single bonds, or a triple and a single, but it needs 4 bonds.
What does central mean exactly?
In the middle. So, like water. Water has oxygen and then 2 hydrogens. So the central atom is oxygen. Then you'll want to count the number of valence electrons present. So for water here, we have oxygen has how many valence electrons? 6, and hydrogens have 1. So we have a total of 2 plus the 6 is 8 electrons. So on the worksheet today it says number of valence electrons. That's what you're going to do. You're just going to add up how many valence electrons there are. And then you're going to show those valence electrons as dots. So for water, we had 6 on oxygen. 1, 2, 3, 4. Now our 5, 6 ones we can put on any of the sides. But already looking at this, I know hydrogen is going to donate 1 here. So I am going to put my 5, 6 out here. And then hydrogen will each donate 1, 1. And then you're going to show the shared electrons as lines. So I'm going to make these lines, dashes. Okay, now I need to compare how many electrons I have drawn to this number. So I have 2, 4. This represents 2, so that's 6, 8. So we have 8 electrons. We would only have 8 electrons, so our numbers match, which is good. And then you're going to check the atom's octet. So remember, hydrogen's that exception. It only needs 2. So here's 2 electrons for hydrogen and 2 electrons for hydrogen. So the hydrogens are satisfied. How about the octets for oxygen? We have 2, 4, 6, 8. So we have oxygen has 8 now instead of 6. So it is has an octet. So that would be the correct Lewis structure. So let's try a few more. Oh wait, before we do that, polyatomic ions. Polyatomic ions are covalently bonded charged group of atoms. So since they're covalently bonded, we will be able to draw Lewis structures. They have covalent bonds. But since they have a charge, you add or subtract that number of electrons. So if it's a +2 charge, what does that mean? Would you add or subtract electrons? Lose 2 electrons because you have more protons now. So you'd lose 2 electrons, lose 2 dots. Or negative charges, you'd add dots. You'd be able to add electrons. The one thing, the last step after you draw the Lewis structure, you want to put brackets around the structure and put the charge outside of the brackets, showing that you added electrons or you subtracted electrons. Around the whole structure. And there is resonance, which are molecules that cannot be correctly represented by a single Lewis structure, like ozone. So this double bond, it's showing we could have made a double bond here with this oxygen, or we could have made the double bond between these 2 oxygens. And so you're showing resonance, that the bond actually kind of resonates between the 2 spots, and they show it with a double arrow. They show both structures, both possible structures, with a double-headed arrow. Atoms in the 3rd period and beyond can form compounds with more or less than octet because they have that D sublevel that's empty. They have a D sublevel empty, and so it's able to sometimes form an expanded octet. You should be able to tell because they'd probably have more than 4 atoms bonded to the central atom, or less than 4. And that's how you're going to be able to tell that it's an expanded or incomplete octet. But some examples are like sulfur. Sulfur can hold 12 valence electrons instead of just the 8. Aluminum is satisfied with just 6. Phosphorus can hold up to 10. And then xenon can have 6 also. Those are just some of the examples. There's a few more, but those are the most common. Okay, so let's draw a few Lewis structures. This one is iodomethane. So what would be our central atom here? CH3I. C, because carbon's in the compound, carbon's in the center. So we have C, we have 3 hydrogens, so I'm going to draw 3 hydrogens around it, and then iodine. Now, how many valence electrons am I able to have? Carbon has how many valence electrons? 4 plus 1 for each hydrogen, so 4 plus 3 plus iodine is how many? 7. Which makes a total of 14, correct? Okay, now I'm going to draw my... No. So there's my 4 for carbon. And then hydrogens each donate 1. And iodine had 7, we said. So I'm going to put 1 here because I can make a bond here. I'm not going to put another one to share unless I absolutely need it. And I don't. So I have, here's a bond, here's a bond, here's a bond, last bond. Do we have 14 electrons shown in our diagram? Yes, we do. Does each atom have an octet? Except for hydrogen, just needs 2. Carbon and iodine, yes, they both have an octet, so this would be our correct formula. Questions on that one? Okay, next one, NH3. What would be central? N, and so we have 3 hydrogens. Okay, how many valence electrons for nitrogen? 5. Hydrogens each have 3, so we have total 8. So let's draw 5 here. 1, 2, 3, 4. And our 5th one can go anywhere, but I know hydrogens are going to have 1 here on each of the sides. So I'm with my 5th one on that free side. Okay, hydrogens each have 1. 3. 1, 1, 1. Okay, we have 8 dots drawn. Yes. Do we have an octet around in? Yes, so that would be the correct structure.
How can you know which
Least electronegative. Okay, H2S. What's central? Sulfur. And you have the hydrogens on top and bottom, or left and right. Doesn't matter. So 2 electrons from the 2 hydrogens. And sulfur has 6, so that's 8. So we have 1, 2, 3, 4. Now my 5 and 6 again can go anywhere, but I'm going to go on top and bottom because hydrogens are each going to donate 1 here. Do I have 8 dots drawn? Do I have an octet around sulfur?
Yes.
Yes. So that was my Lewis structure. Questions so far? Okay, we're going to get into some with multiple bonds, double and triple bonds. Show you how we do that. Carbon dioxide. What's central? We have oxygen and oxygen. Carbon has 4 valence electrons. Oxygens each have 6. That's a total of 16. So carbon has 4. Oxygen has 6. Okay, do I have 16 electrons drawn? I do? Yes, I do. Do I have octets? Ooh, that's where we get tripped up here. Oxygen, this oxygen has 6, or it's missing 1, it has 7. This carbon only has 6, and this oxygen only has 7. I can't just add dots. I have the correct number of electrons. I can move them though. So does this oxygen have an electron that it can share with carbon? Yes, and this carbon has an electron it can share with this oxygen. So we're going to take this electron and this electron, and they're going to share with each other again and make a double bond. So now this oxygen has 2, 4, 6, 8. So this oxygen has an octet now. This carbon only has 7, and this oxygen only has 7. Does it have electrons they can share with each other?
Yes.
Yes. There we go. Those 2 electrons are going to come here, form another double bond. Carbon now has 8 valence electrons, an octet. Oxygen has 8. So that would be our structure. Now, for this example, when we made a double bond, an electron came from 2 different atoms. The electrons can come from the same atom. So both electrons could have came from oxygen to be shared with carbon. It's just the sharing of 2 electrons. It doesn't mean it has to be 1 from each atom. Let's try HCN. What's the central? Carbon central. So we have H and N on each side. Carbon has 4 plus 1, and nitrogen has 5. So we have a total of 10, right? 1, 2, 3, 4. Here's the one for hydrogen. And then nitrogen has 5. Do I have 10? Yes, I have 10 dots. Do I have octets? No. Carbon needs 2 electrons. Nitrogen needs 2 electrons. Do they have 2 electrons they can share with each other? Right. I'm going to move these 2 electrons in. This will be a double bond. And they still each need 1 more, so they're going to take these 2 and make a triple bond. Now, this lone electron pair should be directly opposite of because it wants to be as far apart. It'll be as far apart, so it's going to be opposite. You don't want to show one on top and one on bottom. They would still be paired. And they'd be as far apart from the bond as they can. Questions? Okay, next one, CO3. 2 minus. Carbonate. So we have, we forgot to add them up. 4 plus 3 times how many? 6. 6, that 18 plus 4. What's the 2 minus mean? Adding 2 more electrons. So 24. 1, 2, 3, 4. And we had 6 for each oxygen. Do I have 24 dots? Okay, 22. Yeah. 2 minus, I get to add 2. Where should I add them? Whenever you get to add electrons, add them to the outside atoms. Don't add it to the central one unless there's no other spot for it. So I'm going to put it. Okay. So this oxygen has an octet. This bottom oxygen has an octet. How about the carbon in this oxygen? No. So we're going to have a double bond there. And then this is where I need to put brackets around the whole thing and put a 2 minus to show that I added 2 electrons. Now, this one could also have a resonance structure because, right, you could have had right here. Could have been like that and said, oh, you can't see the O because it's black. And then there would actually be one more, wouldn't there? Because I could have had right? So I actually have 3 resonance structures that you could show. No. Now, there might be a question if it says to show all resonance structures, then you need to show all 3. But if it doesn't ask for that, any of those 3 would be correct. The second 2, you need to show your dots and your brackets, but you could have had the double bond in any of the spots. Last one. I think it's the last one. Yep. 2 carbons. So I'm going to have 2 carbons side by side. And this one has 2 different ways we could do this. We could have a hydrogen and a chlorine on either side. Or you could have hydrogen, carbon, carbon. Actually, let me move the hydrogen over to this other side. I'll have more room. Chlorine. Oh, this is chlorine. So let's see what they look like, if they look similar or not. 4 carbon or 4 valence electrons for carbon. How about for chlorine? 7. And for hydrogen, triple bond between carbons. Right. They both need 2 more electrons. They each have 2 electrons to share with the other. Okay, so that would be a correct formula. Let's try this one. Now remember back when we were talking about central atoms, carbon central, and I said carbon needs 4 bonds. There's really no way to get this bond to be 4. You cannot have a quadruple bond. It doesn't happen. So this would not be a structure that would be, when you got to that point, you should be able to see that one wouldn't work. So it would be the bottom one. Okay. Those structures are a little bit of trial and error. In class, if you want to use the whiteboards, because it's easier to erase electrons and all that stuff, I have the little whiteboards that you can use. But you can do that. But a lot of it's trial and error. If it doesn't work and you count in the octets, you can't add electrons, but you can move electrons around.